Hi everyone, I'm Bradwell. Let's look at this physics problem right here. We have a mass connected to a string, which is connected to a ceiling. And the mass is traveling in a circular path like that, in a circle. The string is at an angle of theta with respect to the vertical. The mass has a mass of m. And the string has a length of L, which is also the distance between the ceiling and the floor. The question asks, if I cut the string, what horizontal distance will the mass cover from the moment I cut the string to the moment the mass lands on the ground? So first, I'm going to draw some free body diagrams for the mass. So here's the mass. We know it has a weight, the force of mg, and then we know there's tension on it that's directed in this direction. And then this is an angle theta. So now let's write F equals ma for the y direction. Now, the net forces in the y direction should cancel out because the mass is not moving up or down. It's only moving in the x direction in a circular path. So it's moving like this, but never like that. So we see there's the y component of tension will be t times cosine theta. And then there's a mg going down, so minus mg equals 0. Now let's draw F equals ma for the x direction. Because it's moving in a circular path, the acceleration will be v squared over r. So my equation should look like that. The only force in the x direction is this, the x component of tension, which will be t times sine theta. T sine theta, that's only x force, will equal mv squared over r, where r is the radius of this circular path. That's going to be equal to L times sine theta, L times sine theta. Now, t is an unknown in this problem, so let's get rid of it. Let's get rid of t by solving for t in this equation and then substituting that value for t into here. So we have t cosine theta equals mg, and then we have t equals mg over cosine theta. Now let's plug that into here. So then you're going to get mg over cosine theta times sine theta. That will give you tangent theta, because sine over cosine is tangent, equals n v squared over L sine theta. Let's get rid of the n's. So we have this. And then let's solve for v, because it's the only unknown in this equation. So I'm going to get v equals, I'll skip a few algebra steps. I'm going to get GL sine theta tangent theta, and then square root of all of that. Now I have my v. Now, that's the velocity of the ball when it's traveling. So when I clip it, the ball will be moving in the x direction only, and then it'll fall straight to the ground. So that means now that I have my velocity, the only other thing I need to calculate the horizontal distance the ball will travel is its height from the ground. because that will determine how long the ball is in the air. So I'm going to erase all of these equations that I wrote since I got what I needed. V. Now I'll leave that there. Now, what is this height of the ball from the ground? Well, we can solve that by calculating this height right here, and then subtracting this quantity from L, because this distance minus this distance will get you this distance right here. So what is this distance, the ceiling to the ball? That's just going to be L times cosine theta, adjacent over hypotenuse is cosine. So L times cosine theta is that distance. So L minus L times cosine theta is going to be this distance. So L minus L cosine theta. So now we have that. We're going to write H equals, I'll factor out the L. You'll see these two quantities are the same. Now, how long will the ball take to fall to the ground? Well, we'll solve for that by saying H equals 1/2 AT squared, where A is G, since it's in free fall, so 1/2 GT squared. So the time it takes, substituting H for this will just get you, I'm gonna skip some algebra steps. And square root all of that. This is the time it'll take for the ball to fall to the ground. Now, all I have to do is multiply v and t, velocity times time, to get the horizontal distance this ball will travel. So that means d just equals v times t. I'm going to rewrite v up here. So here. All right. Now v times t will equal d. This G will cancel out. And since I have an L and an L right here, that will factor out. So now let me rewrite it as L times the quantity 2 times 1 minus cosine theta, all times sine theta tangent theta. So there's your answer.